You know that feeling when your code just doesn't run and you're convinced that your computer just personally hates you? Yeah, well, that was me for quite a while. But somewhere between all of the red error messages, the late night debugging, and the tiny victories of getting a problem to finally work, something weird happened. I realized that learning how to code didn't just make me better at solving very technical problems, it also quite reviewed how I think about life itself. I know this is very deep, but bear with me on this one. So in this video, I want to talk to you about how coding changed the way I think, and not just about computers, but about learning, about problem solving, and honestly, just how I deal with the world. For those of you that do not know me, hi, my name is Joanna, and I work as a quantitative developer in London and have graduated with a degree in mathematics from the University of Oxford just over a year ago. I've had my fair share, I want to say, of experiences with coding along the way, so let's dive straight into it. Let's start with the most obvious one, which is patience. Before I learned to code, I was one of those people who'd get really frustrated when something didn't work immediately. If I couldn't solve a maths problem within like 10 minutes, I would decide subconsciously that it was unsolvable. If a recipe went wrong, I would think, oh, I'm just not made to cook. And then I met syntax errors. There's nothing quite as humbling as realizing that your entire program failed just because of a missing semicolon or because you forgot an indent. I do remember one particular Oxford problem sheet where I tried to simulate a random walk in Python and it just kept producing the same number. For a while, I genuinely thought that I discovered something very profound about stochastic processes until I realized I just set the random seed inside of the loop. So yeah, the main takeaway here is that coding gives you this very brutal but fair kind of feedback. It just never lies. You can't talk your way out of a bug or get partial marks for having almost the right logic. When I started working as a quant developer, this became even clearer. I once spent 2 full days trying to fix a production script that refused to execute. I was convinced there was a deep numerical instability somewhere until I found that someone just literally named a variable the same as an inbuilt Python function. That moment was very humbling, but it was also empowering. You learn that failure isn't personal, it's informative. You stop panicking and start debugging your own thought process. And that shift from frustration to curiosity genuinely changed how I handle everything. So when something breaks in my life right now, my first instinct is not to declare it doomed. It is to say, okay, what's not connecting here? And that is just debugging in code and in life. The second big thing was to think in systems. Coding forces you to zoom out and see problems as collections of smaller integrating parts. You start noticing dependencies, bottlenecks, feedback loops, and not just in your programs, but in how everything works. When I was writing my university dissertation, I had this very chaotic notebook filled with mathematical derivations, code experiments, and simulation results. At first, it all looked really random, but once I started thinking like a programmer, I began to modularize it. So I separated the data collection, the analysis, and the interpretation into very clean sections. So it was just like turning a very messy life into a clean API. And that is precisely how I approach my day-to-day work as a quant developer. When a system misbehaves, you don't just fix one number. You trace the data pipeline, the model, the deployment script. You think in layers essentially. And it's absolutely amazing how this spills over into daily life. If I'm overwhelmed, I mentally break things down into functions, one for work, one for gym, one for content, one for everything else. And before you say anything, no, this is not about being robotic, it's about seeing the architecture behind the chaos. I would say that systems thinking reminds you that everything complex is built from simple parts that just intertwine with each other. You know, that project that feels impossible, well, that's most likely just a bunch of solvable sub-processes or subroutines pretending to be one monster problem. Coding taught me that the clarity is not found by thinking harder, it's found by structuring better. Abstraction is one of those things that sounds really intimidating, but it's secretly everywhere. In programming, it means simplifying complex systems, hiding details that you do not need right now. When I first started learning object-oriented programming, I hated it. And by the way, I'm absolutely convinced that this is a universal experience. I just did not get why we needed classes or inheritance when functions just work perfectly fine. But the moment my code base hit 500 lines, well, I suddenly understood. And abstraction is the one thing that keeps you sane in that situation. During my university years, that skill became academic gold. My supervisor once said, if you can't explain a concept in one equation or one analogy, you don't really understand it. And that's basically abstraction explaining words. It's also how I think now, and not just about code, but about life. If I'm overcomplicating something, I stop and ask, what's the simplest version of this idea that still works? And that mindset, I would say, helps everywhere. From explaining technical ideas to non-technical teams at work, to explaining maths on YouTube, you're constantly balancing simplicity and precision. Because abstraction isn't just about hiding details, it's about knowing what details actually matter and hiding the noise. There is a saying that I absolutely love, which goes, to error is human, to debug is divine. Debugging is the art of understanding what went wrong without taking it personally. In my first few months as a quant, just like in everyone's first job probably, I spent ages chasing bugs that weren't actually bugs. Sometimes the code worked perfectly, my assumptions didn't. Debugging isn't just fixing, it's testing your own logic against reality. I want to say that it also has made me calmer, so when something fails, I trace it back instead of spiraling. I look for where the information flow broke. It's analytical and it's also strangely therapeutic. Now let's talk about how you can actually train this way of thinking, and not just for coding, but for learning anything complex. One of the best ways to build that logical debugging style mindset is through Brilliant, who are very kindly sponsoring today's video. So if you've ever found yourself staring at a screen thinking, I understand this in theory, but why doesn't it actually click when I try to code it up? Well, Brilliant is genuinely perfect for bridging that one gap. Their interactive courses in computer science, maths, and data science don't just tell you the right answer, they walk you through that thought process, that logic step by step, letting you play with the concepts until they actually start making sense. When I was first transitioning from pen and paper maths to coding, to writing actual code at university, that kind of visual, hands-on learning made a huge difference for me. I remember trying out Brilliant's algorithmic thinking course and realizing, oh, this is what's really going on behind sorting and searching. It felt like I was learning how to see the structure inside the problems, not just memorize formulas. They also have an amazing probability fundamentals course, which I think every quant or data science person should go through. It takes you through very intuitive examples like predicting card hands and coin flips, all the way to more advanced ideas like basis theorem and random walks, random variables, in a way that actually sticks. Whether you want to get better at debugging algorithms, strengthen your maths intuition, or just rekindle your love for logical problem solving, Brilliant makes learning fun, interactive, and surprisingly addictive. You can start learning on Brilliant for free using my link brilliant.org/Ioana Roman, which you also have down in the description below, and you will also get a 20% off an annual premium subscription. Alright, thank you once more to Brilliant for sponsoring today's video. Let's get back to debugging our thoughts. If coding teaches you one very important life skill, it is iteration. You never write perfect code on your first try. You write something bad, then you write something slightly better, then slightly better again until it finally works. And this idea became my absolute mantra during my dissertation. I remember trying to optimize a simulation for literal hours, changing one parameter, running it, waiting, failing, adjusting again. It wasn't glamorous, and it definitely required quite the amount of caffeine to get me through, but it taught me something very profound, which is that progress is literally just loops of improvement. Now I apply that principle everywhere, whether that's fitness, work, YouTube, life. You don't wait until it's perfect, you just get version 1.0 running and improve as you go. And that's really how real-world coding and life works. You never finish learning, you just level up your build. Iteration is self-improvement written in Python. People assume coding is this very cold, very logical thing, but honestly to me it's also art, as cheesy as it may sound. Writing code feels like writing a story. There is a problem, there is a journey, and there is an ending where everything finally runs happily. It's logical, yes, of course it's logical, but it's also really creative. The way you name your variables, the way you structure your functions, design systems, that's really personal. When I worked on my first Quant model, I realized something magical. I was creating something both rigorous and beautiful. Code that runs efficiently feels almost poetic. Coding trains your mind to balance reasoning and imagination. And that's what makes it such a powerful way to think. So yeah, coding did change the way I think. It made me more patient, it made me more logical, it made me more curious, but also more creative, more grounded, and more forgiving of mistakes. And honestly, I think everyone should experience this shift at least once. Because even if you end up never writing a single line of code professionally, you'll still come away with something deeper, a mindset that helps you debug life itself. Very profound way to end this video, I know. If you enjoyed this video and found it helpful, don't forget to hit that like button, subscribe for more content about maths, about coding, quant life, and follow me on Instagram for behind the scenes bits of both some Oxford nostalgia and quant chaos. Thank you so much for watching, guys, and happy debugging until the next time.
I'm sick of daydreaming, I just want the feeling of you in my bed. I'm down to just waste time right below your waistline. Want you by my head.